I just want to add a few things to the gel electrophoresis video that I just finished. There's a few parameters that I didn't mention that influence the rate of migration of the DNA molecules during gel electrophoresis, and there's also some parameters that don't influence, and I just want to mention a few of those right now. So let's just do a little line here. So a few things that actually do influence it. So the percentage of the agarose in the gel matrix. So if you have a very high percentage of agarose, you're going to have these tightly wound molecules that have tiny pores. So if you have this huge DNA molecule, it's not going to migrate very far, if at all. But if you have a little bit less of a percentage of the agarose, you'll have slightly larger pores that allow for further migration of the smaller molecules as well as the larger molecules. So another one would be, like I said, the topology of the actual DNA molecules. Topology. So the shape, whether it is a supercoil, a relaxed circular, or a linear molecule. So those things I talked about in the last video, you can check that out. Also, a pretty important one would be the voltage applied. So you always want to be less than 5 volts per centimeter. And if you went any higher than that, you might actually cause a little bit of smoke to come out during your experiment from the gel. So you want it to be below 5 for sure, and the voltage that you use, depending on your experiment, will definitely affect how far the molecules travel. So now we'll move on to some things that don't influence, that you might think do. No influence. So the percentage of the GC in the molecule. So GC is just the base pair between guanine and cytosine. So in an experiment like where you're denaturing a molecule, you'll notice that the higher the GC content, so if you had this curve like this, and up here you're getting to denaturing, and this is the temp, and this is the percentage denatured. So if you had a low GC content, it would probably have a denaturing point here, but if you had a high GC content, it would probably be denatured here. And the reason behind this is because G and C have 3 hydrogen bonds, whereas A and T only have 2. So there's more bonds for the temperature to actually denature. There's more bonds to be broken when you're dealing with GCs, but that actually doesn't influence the rate of migration of the DNA molecules during gel electrophoresis. So that's basically it for some factors that don't influence it. There's obviously we can get a little bit more into the details of this in further videos, but for now we're gonna leave it at that. So quickly, just to solidify this point here, let's pretend that you had one molecule that was 25% GC and another one that was 75% GC. And the rates of both of these would be equal. They would be no different as long as they had the exact same number of base pairs, regardless of whether they're GC or not. One could be 100% GC and one could be 0% GC, and they would still migrate at the same rate as long as their size and their topology were the same.